Let's go ahead and look at your answers for the practice printable for Slope of Sprouts mid-school math lesson. Number 1 and number 2, they did not give us any scatter plots or lines of best fit. They only gave us the equation, and we're supposed to figure out what is going on based on this equation. So the equation for number 1 is y equals negative 4.3x plus 80.5. They do give us information about the axes. The x-axis is recording the number of hours of exercise per week, and the y-axis is showing our beats per minute for our resting heart rate. So what does the slope mean, the negative 4.3? Well, the slope means that the resting heart rate will decrease, because it's negative, 4.3 beats per minute for every hour of exercise per week. So what does the 80.5 stand for? So the y-intercept, the 80.5, means that when x is 0, when we have not exercised anything at all during the week, our resting heart rate should be at about 80.5. For question number 2, the equation was y equals 19.35x minus 870. So what are we talking about here? The x-axis is telling us the temperature in degrees Fahrenheit, and the y-axis is telling us the dollar amount of ice cream sales. So this slope of 19.35 is telling us that the ice cream sales will increase by $19.35 for every degree that the temperature goes up. But what in the world does this negative 870 mean for the y-intercept? This means that when the y-intercept means that at 0 degrees, when x is at 0, the ice cream sales would actually be at a negative $870. Now, this really isn't reasonable in this context, but as far as the equation, just like the one we looked at in Monday's practice page, we do need this number, even though it doesn't seem reasonable as far as for the graph, we needed to be able to interpolate and extrapolate data. For number 3, we have a lot going on here. First of all, we're looking at the study time and how this affects our GPA. So just by looking at this, I can see I have a positive linear association, and I have my line of best fit already drawn in here. They gave me 2 points to use to be able to find my slope. So like we did yesterday, we're going to subtract our y values, and then we're going to subtract our x values to find out what our slope is. So I took my y value, 3.25, and I subtracted 2.25 to find a value of 1 for my rise. For my run, I'm going to take 7 minus 4 to find a value of 3. When I take this fraction 1/3 and I put it into a decimal, I get 0.33. Now, to find my y-intercept, I could look at the graph, but it looks like it's going to be slightly below 1. I just don't know how much. So I'm going to use my slope-intercept equation again, plug in my slope, and plug in just this first point here. So my y value from my first point was 2.25, plugged in my slope, and my x value was 4. So when I multiply these two factors, I get 1.33, and I now have a one-step equation to solve. So to be able to get b by itself, I'm going to subtract 1.33 from both sides, and I'm going to find out that my y-intercept, b, is actually 0.92. Using my slope and my y-intercept, I'm going to create my equation, y equals 0.33x plus 0.92. So what does the slope mean in this context? For every extra hour of studying, your GPA will likely increase by 1/3 of a point, or by 0.33. So what does the y-intercept mean? This means that when you don't study at all, when x, your hours of study time, is 0, your GPA will be about a 0.92. And finally, we have the height chart for Alicia. We had to fit in a line of best fit, and this is where things could get a little bit different from my answers to your answers. So when we go through this, make sure that they are very comparable and close to the answer. If you should have any questions, go ahead and raise your hand, and I will come around and we can determine together if you got it correct or not. So we draw our line of best fit, and I found 2 points. So over here at the age of 7, I found out that Alicia was 40 inches tall. And over here at the age of 12, I found out that she was 52 inches tall. Using my 2 points, I'm going to subtract my y's and subtract my x's to find a fraction of 12/5, which is equivalent to 2.4. Now you will notice that I have breaks in both of my axes, in my x and my y axis. So to be able to find the y-intercept, I am going to have to use the slope-intercept equation. I cannot use my graph at all for this. So I'm just going to use this point here, my 740 point, and my slope, which is 2.4. So plug in the 7, plug in the 40, plug in the 2.4 so that I can find b. When I work this all through, I find out that b is 23.2. When I write my equation, plugging in my slope, plugging in my y-intercept, I get y equals 2.4x plus 23.2. So what this means is the y-intercept when she was 0 years old, that means she was at 23.2 inches tall or long as a baby. The slope, 2.4, for every year, for every birthday that Alicia has, she was growing an average of 2.4 inches. So using this equation, we are going to be able to do some interpolating of data here, maybe even some extrapolating. I'm not exactly sure. They might all be inside. But by using the equation, we can get a very precise answer and we don't have to do any estimating in the graph. So we're going to use our equation to predict Alicia's height when she was 16 years old. If you remember, her age was on the x-axis. If you don't remember that, you can check back, and age is the independent variable, so that has to go in for the x. So I'm going to take the 16 and I'm going to plug it in for x. So that means I'm going to take 2.4 times 16 plus 23.2. Now I just have a mathematical equation. I multiply these two factors together, add the 23.2, and I can find that when Alicia is 16 years old, she will be 62.6 inches tall. We can also use the equation to predict Alicia's age when she was 27 inches tall. I think this is where we will be extrapolating data because 27 inches isn't even on our graph. Now, finding out where 27 inches would be, that is going to be our y value because that is on the y-axis. So I'm going to plug in 27 for y. Now I have just a two-step equation. 27 equals 2.4x plus 23.2. So to solve the two-step equation, I'm going to subtract 23.2 from both sides, leaving me with 3.8 equals 2.4x. Then I will divide by 2.4 on both sides, and I will find that when Alicia was 27 inches tall, she was only 1.6 years old.